this is the 6th lecture of unit 3rd, recurrence relation. Actually, we know that the recurrence relation can be generated from the numeric function. We have made the 3-4 videos on the numeric function and generative function, so you become familiar from the numeric function. So we can generate the recurrence relation also with the help of numeric functions. So either we can generate the generative function with the help of numeric function, or numeric function is a very small things, is not so big, because in the series in the form of geometric progression is called numeric function. Just the coefficient of z to the power r in the generative function is also known as numeric function, denoted by ar. So ar equal to 3 to the power r. If you will put 0, then you will get this term, this term, this term, and then you will put in the az series a0 z1 a1 z1 a2 z2, then you will get the answer of this series. So now we are going to generate some different type of sequence, okay, as you have studied in the C language, Fibonacci sequence, okay, Fibonacci sequence number. So two things we have already. Just reoccurrence means just if you want to calculate the next term, then the previous term should also be calculated, okay. Means that for just you are doing anything, for the next step your previous step has been completed. If your previous step had not been completed, you can't go ahead, okay. So the all the previous step has been finished, then you can go to the next step, okay. So the previous value should be calculated first, then you can calculate the next term. Means that the simple thing is that next value is totally depend on the previous value. If previous value has been calculated, you can find the next value. That's the simple thing. This is called reoccurrence. One function should be called by itself for the different value. For ar is a function, so it is called for calculating the ar. You have to calculate first ar minus 1, because ar minus 1 is the first term, previous term. So the first previous term should be calculated, then you will calculate the term next term ar, okay. So if you want to calculate ar, then it should be calculated ar minus 1 first. If you want to calculate ar minus 1, it should be calculated to ar minus 2 first. Ar minus 2 should be calculated ar minus 3. So this is the sequence. So if we have 1 1, the two basic numbers, if we have 1 1, two numbers a0 and a1, then we can find the a2. So for a2 we have the relation ar minus 1 plus ar minus 2. So if you will put equal to r equal to 3, then you will get, if you want to find r equal to 2, then you should put here a2 equal to a 2 minus 1, that is 1 plus 2 minus 1, that is 2 minus 2 into 0. a0 a1 already given, so basic value has been already given. 1 plus 1, it becomes 2, so a2 equal to 2, okay. So because we already know the calculated your previous value, so that we can put here and find the solution of a2. Now we want to find the a3. a3, just put the value in this relation. 3 minus 1, that is 2, a2 plus a1. So a2 value already calculated, just I have explained already. Previous value should be calculated first, then you can calculate the next value. So a3 is the next value, a2 is already calculated, and a1 is given, so just value is 3, okay. So if you want to find the a equal to 4, then you should put the value of 4 minus 1 3, 4 minus 2 2, so it becomes a3 and a2. a2 and a3 already calculated, then you will able to calculate the a4. just 3 2 plus 1 3 plus 2, that is 5. Okay, so this type of series has been generated. 2 3 2 or 3 5 5 3 8 8 5 13 13 or 8 21 21 or this become 34 dash dash dash. Okay, so this is a Fibonacci sequence. Solution of this recurrence is this. First we have to discuss the solving method for the recurrence, then we can get the we will able to find the solution of this recurrence. Okay, so first we have to just we have to discuss about the solution of the recurrence relation, then we will able to find the solution of this recurrence. Okay, so this is the recurrence for Fibonacci series. Recurrence relation is also known as the difference equation. Recurrence relation is also called a difference equation. Okay, now the general form of the recurrence is that any numeric function with constant, numeric function with constant, numeric function with constant, numeric function with constant, which is the highest number is subtracting here is k. So the order of this recurrence is kth order. If 1 is subtracted here, so first order recurrence relation. If 2 is subtracted here, second order recurrence relation. So the k is subtracted from here, so this is called kth order recurrence relation. Now in this recurrence only the 1 is the highest number which is subtracting first order recurrence relation, and now in this recurrence and in this recurrence 2 is subtracting, so it is a second order linear recurrence relation. Okay, so in this fr is a function of r. They have any expression in terms of r, any constant to the power r, or any constant may not be 0. Constant may not be 0, it may be not equal to 0, it may be any value, either 4 10 42 something may be constant. So there are 3 components should be available in the right hand side: constant, constant to the power r, or expression. Okay, I will explain later. Just so if you will have the 2 equations of the same, one have the 0 equal to 0, or second have the fr function of r. If you have the 0 in the right hand side, then you will able to find only the homogeneous solution. Then you can find the solution only the homogeneous solution. If you will have any function of r in the right hand side, then you will be able to find the 2 types of solution: homogeneous solution and particular solution. Okay, and if you will add these two, homogeneous and particular, then you will find the total solution. If you will add the homogeneous AP equal to A, it becomes the total solution. So the very simple thing is that if the actually we have equation, suppose that we have a equation which have the 2 roots. Okay, actually the scenario is that if we have the recurrence, and from the recurrence you can understand that all the numeric function term should be available in the right hand side: AR minus 1, AR minus K, all the numeric function term. So they should be lie always in the left hand side. Only the right hand side it should be the function of R. No numeric function should be available in the right hand side. Okay, so if we have the relation AR equal to, so this is wrong, because here it should be the right hand side. In the right hand side it should be the only function of R, but the function of R is not here, so it should be 0. So we can write in this way: AR minus 1 minus AR minus 2 equal to 0. Okay, so just we have to make the auxiliary equation AU xi, sorry, au xi li ary ऑक्सिलरी इक्वेशन या फिर करेक्टरिस्टिक इक्वेशन, जस्ट एक्चुअली इन द कोड करेक्टरिस्टिक इक्वेशन, sorry, characteristic equation. So we know that is a characteristic equation or auxiliary equation. Okay, a u x I l I a r y, auxiliary. Okay, so now we have to create, just we should write here all the constant first of this equation. So we have 1, -1 and -1 equal to 0. Just apply alpha, alpha and alpha. Okay, just you should start from here and reduce to 0. Apply the alpha to the power 2, alpha to the power 1, alpha to the power 0. So it becomes alpha square minus alpha or -1 equal to 0. The factor of 1 should be the just like that, it is the difference of this factor should be 1, but it is not possible. So you should compare as a alpha square plus का b alpha और plus का c alpha equal to 0. So a equal to 1, v equal to -1 and c equal to 1, sorry, c equal to again -1. Just apply the formula alpha equal to -b plus minus, as you know क्वाड्रेटिक इक्वेशन को सॉल्व करने का फॉर्मूला b स्क्वायर माइनस 4ac और अपॉन 2a. Okay, so just put the value -1 it becomes the +1 plus, क्योंकि minus sign is here or you should put the -1 here, so it becomes like this, minus or -1. So -1 से multiply it becomes +1 here, or square of the negative number, the square of this -1 is equal to +1 plus 4a यानी कि -1 और यानी कि c यानी कि -1 और divide by 2 into 1. So the solution of this number is that 1 plus minus under root b square minus 4ac, that is 5 divided by 2. So the two values of this two root has been come. First root is alpha 1 plus root 5 divided by 2, and alpha 2 second root is equal to 1 minus, because first time we should take the plus sign, second time we should take the minus sign. 1 minus root 5 divided by 2. So we have the two roots. Now we are going to discuss about the homogeneous solution. So we should save this slide just like that, and I am going to open a new paint. In the series, in the recurrence relation, if we have the two roots in the equation and they are distinct, so if they are distinct, so just you should write the homogeneous solution denoted as a ARH. first take any constant a1 root to the power r, root to the power r plus any another constant, take root to the power r. If suppose that if b have the three roots or it is also distinct, so you can write a3 and root to the power r. Okay, this is the case of first case. This is called case 1, CASE. This is a case 1 if all the roots are distinct. Second case, if all the roots are repeated, suppose that alpha 1, alpha 2 and alpha 3 have the equal value, so just you should write the homogeneous solution ARH in this way: constant r to the power 0, constant r to the power 1 plus constant a3 r to the power 2. Just this value should be always less than 1 from the total number of roots. Total number of roots are 3, so it should be 2 here, only 2 here, and the root to the power r, root to the power r. Just if the root is repeated, for example, so we can explain in this manner. We have the two roots are repeated, so we will write the solution for this, but before this I will explain something. If the roots are distinct, they just you should write the constant root ki power r, constant root ki power r, constant root ki power r. If the roots are repeated, so you should write the root. If all the roots are repeated, means all the roots have the equal number, equal value, so you should write in this way: just root to the power r, this root to the power r, and just constant r ki power 0, constant r to the power 1, constant r to the power 2, constant r ki power m minus 2, constant r ki power m minus 1, because the multiplicity, any repetition of the root was m, so the power should be here m minus 1, highest power m minus 1. So if b have the three roots are equal, if b have three roots are equal, so it should be the highest power 2. Okay, so for this recurrence we have the roots this, so the solution is that constant 1 plus root 5 divided by 2 to the power r plus any constant 1 minus root 5 or divide by 2 to the power r, power 2 nahi, sorry, r. So this is the final answer. So we can show you in the PowerPoint. This is the final answer. Constant root to the power r plus constant root to the power r will be the homogeneous solution of the Fibonacci series. Getting my point? So now these are the references. Thank you for watching this video. Thank you.